Hello everyone, myself Dr. A. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discuss about mesh analysis and nodal analysis. A very first topic in this concept is loop. What is loop? Loop is a closed path traced by circuit elements. Closed path traced by circuit elements means over here in a given network, total number of elements. How many elements? Two active elements V1 and V2. Remaining elements are resistors R1, R2, R3, R4, R5, R6, R7, R8. So these are passive elements. Here how many number of loops in a given network? How many number of loops in a given network? 1 loops, closed path. This is the closed path. V1, R1, R4, R6. This is the closed path. Loop 1. Next, this is the closed path. R2, R5, R7, R4. Second loop. Loop 1, loop 2. This one. R3, V2, R8, R5, closed path traced by circuit elements. Loop 3. Next loop. This one. R1, R2, R5, R7, R6 and V1. Loop 4. Next. R2, V2, R3, V2, R8, R7. Next, R4, loop 5. Next, final one, this one. R1, R2, R3, V2, R8, R7 and R6, V1. This is sixth loop. Possible number of loops in a given network. Total 8. The next definition in this concept, mesh. What is mesh? What do you mean by mesh? Mesh is a kind of loop which does not cross another loop. So it is also loop. This one is a loop. This one is a loop. But here fourth loop is not a mesh. And fifth loop is not a mesh. Next sixth loop is not a mesh. Only 1, 2, 3 are the meshes. Because here the loop 1 does not cross another loop, second loop. So individual loops are called as meshes. So this loop and mesh concepts in the mesh analysis are mostly used. Next, what are the steps to apply mesh analysis in a network? So these are the steps to solve mesh analysis in a network. So the main purpose of mesh analysis is to determine the current flowing through the each element and voltage across the each element. Another method is also there. That one is nodal analysis. Same purpose, to find out the current flowing through the each resistor and to find out the voltage across the each resistor. Mesh analysis and nodal analysis. But the best method to find out the current flow into the each resistor is the mesh analysis. The best method to find out the voltage across the each resistor is the nodal analysis. Here the steps, total 5 steps. You are supposed to follow total 5 steps in the mesh analysis. First, determine possible number of meshes. Identify number of meshes. So here for this particular network, possible number of meshes 3. 1, 2, 3 only, not 6. 6 are loops. Next step, assign the mesh currents in terms of I1, I2 and I3. Assume the mesh currents I1, I2 and I3 in clockwise direction. So this is I1, this is I2 and this is I3 till IN. If n number of meshes in a given network, so I1, I2, I3 till IN. Next, step 3. In each mesh, apply KVL, Kirchhoff voltage law. In each mesh. Step 3. Apply KVL in each mesh using Ohm's law in terms of I1, I2, I3 till IN. So what is Ohm's law? Algebraic sum of all voltage across any element is directly proportional to the current. What is KVL? Kirchhoff voltage law. Algebraic sum of voltages in a loop equals to 0. Next step. After applying KVL in each mesh, you will get mesh equations, KVL equations. Solve that KVL equations, mesh equations using Cramer's method or inverse matrix method. You will get only mesh currents, this I1, I2, I3 till IN. So these are the mesh currents. So our aim is to determine the current flowing through the each resistor. Current flowing through the each resistor means here from the mesh currents you can calculate the branch currents. R1 current, R2 current, R3 current, R4 current, R5 current, R6 current, R7 current, R8 current. So step 5. From the mesh currents, these are the mesh currents. Mesh currents are different, branch currents are different. So these are the branch currents. From this mesh currents, you can determine the branch currents. Step 1 is determine the possible number of meshes. Step 2 is assign the mesh currents in I1, I2, I3 in clockwise direction. Step 3 is apply KVL in each mesh. And step 4 is solve that KVL equation and you will get I1, I2, I3 mesh currents. Next, from the mesh currents, determine branch currents. Let us take one example. Determine current flowing through the each resistor using mesh analysis. So here is the network over here. In a given network, determine current flowing through the each resistor means here 0.1 ohms resistor current, 10 ohms resistor current, 5 ohms resistor current, 20 ohms resistor current, 0.2 ohms resistor current. So for that purpose, you can determine, you can apply mesh analysis here. So the step 1 is identify possible number of meshes. Here step 1. Solution. Determine possible number of meshes. Here how many meshes? Here 1 and 2. Mesh 1, mesh 2. The step 2 is assume the mesh currents in I1 and I2. So in clockwise direction. So here you can see the direction and I1 and I2. I2 current direction is in also clockwise direction. After that, step 3, apply KVL in each mesh using Ohm's law. KVL means algebraic sum of total voltages in a loop equals to 0. So in the first loop and second loop, apply KVL. So here 2 volts is a rising volt and 0.1, 10 and 5 are resistors. So voltage drops. First loop, if you apply KVL in the first mesh, 2 minus 0.1 I1 minus 10 I1 minus 5 I1 minus I2. 2 is the rising voltage, 2 plus 2, 0.1 minus voltage drop. So V is equal to, using Ohm's law, V is equal to IR. Here that voltage equals to I into 0.1. Dropping means minus 10 I1 minus 10 I1, 5 I1 minus I2. This one is minus, is equal to 0. Algebraic sum of voltages in a loop equals to 0. Simplify this equation. 10 plus 5 plus 0.1, 15 I1 minus I2 is equal to 2. So the simplified equation, this is equation number 1. In the second loop, second mesh, apply KVL. Minus 5, I1, I2 minus I1, 20, I2, 0.2, I2, minus 4. This is rising voltage but in reverse direction, plus and minus. Current is flowing from plus to minus. So here you can take minus 4 is equals to 0. Algebraic sum of voltages in a loop equals to 0. The simplified equation, minus 5I1 plus 25.2 I2 is equals to minus 4. This is equation number 2. These are two equations. Solve these two equations using Cramer's method or inverse matrix method. Step 4. You will get I1 and I2. Convert this into matrix method. 15.01 minus 5, 2, minus 5, 25.2, minus 4. The solution for this one, I1 equals to 0.0855 amperes, I2 equals to minus 0.1417. So these are only mesh currents, not branch current. We need 0.1 current, this one. 10 ohms current, 5 ohms current, 20 ohms current, 0.2 currents. Here I1 and I2 are branch mesh currents only. From this mesh currents, calculate the branch currents. Step 5. From the mesh currents I1, I2, determine branch currents. Here current flowing through the 10 ohms resistor is the I1. That one, this I1 is 0.055 amperes and 0.1 ohms is equal to same I1 current, 0.0855 amperes. Next I2 current, 20 ohms current is the 20 ohms current. These two are connected in series, same current flows to the each element. Now here I2 current, this one, 20 ohms current, 0.2 ohms resistor current is same, that is loop current. In terms of mesh currents, loop currents, minus 0.1417 amperes. Next current flow into the 5 ohms resistor. This is the 5 ohms resistor current. I1 minus I2 from the top to bottom. I1 from bottom to top, I2 minus I1. Here the top to bottom current is I1 minus, if you take bottom to top, I2 minus I1. For that particular case, 0.2272 amperes. Next problem, second problem. Determine current flow into the each resistor using mesh analysis in a given network. Solution for this. Step 1. Determine possible number of meshes. Mesh 1, mesh 2, mesh 3. Total 3 meshes. Next, step 2. Assign the mesh currents I1, I2 and I3. This one in clockwise direction only. I1, I2, I3 in clockwise direction. Step 3. Apply KVL in each mesh using Ohm's law. So next, first one, 15. 15 is equals to 1000 I1, 47 I1 minus I2 is equals to 0. The simplified equation, 1047 minus 47 I2 plus 0 I3 is equal to 15. There is no I3 term here. 47 I2 minus I1, 220 I2, 150 I2 minus I3 is equals to 0. Minus 47 I1, 220 plus 47, 150, 417 I2 minus 150 I3. KVL equation in the third mesh, 150 I3 minus I2, 470 I3, 100 I3, 0 I1 minus 150 I2 plus 570 I3 is equals to 0. Equation number 1, 2, 3. From these three equations, first convert into matrix form, then find out the currents I1, I2 and I3 using Cramer's method. Solve these KVL equations and determine the mesh currents. So 1047 minus 47, 0 minus 47, 417 minus 150, 0 minus 150, 570, I1, I2, I3, 1500. The solution for this, I1 equals to 0.0144 amperes, I2 equals to 0.017 amperes, 0017, I3 equals to 0.004 amperes. 14.4 milliamps in the milliampere, 1.7 milliamperes and 0.4. These are mesh currents. From the mesh currents, determine branch currents. 1000 ohms resistor current. First, 1000 ohms resistor current means I1. This one 14.4. 220 ohms resistor current is I2. And 470 ohms resistor and 100 ohms resistor current I3. 150 ohms resistor current is I2 minus I3. And 47 ohms resistor current I1 minus I3. This one. 12.7, 13.3, 0.4. If you want voltages across each resistor, you can determine the voltages also. Just multiply with branch currents with its individual resistances. Here, voltage across 1000 ohms resistor means this current into 1000. Voltage across 220 ohms resistor means this current into 220. Like this we can determine the current voltage across each resistor. Question number 3. Determine current flow into each resistor. Here, possible number of meshes. Mesh 1, mesh 2, mesh 3. This one. Mesh 1, mesh 2 and mesh 3. Step 2. Assign mesh currents I1, I2, I3 in clockwise direction. Next, apply KVL in each mesh using Ohm's law in terms of I1, I2 and I3. First one, 8 1 into I1 minus I2, 2 into I1 minus I3, 3I1 minus I2 minus 2I3 is equal to 8, the simplified equation. Next, 10, 4 into I1, I2, 3 into I2 minus I3 minus I2 minus I1. This one minus I1 plus 4 plus 3 plus 1, 8 I2 minus 3 I3 is equals to 10. On the third mesh, if you apply KVL, 2 into I3 minus I1, that is minus voltage drop, 3 into I3 minus I2, that is minus voltage drop, 5 into I3 minus voltage drop, and this is current is flowing from minus to plus plus 12 is equals to 0. Minus 2 I1 minus 3 I2 plus 10 I3 is equals to 12. The simplified equation of this one. Equation number 3. Now here we have three equations I1, I2 and I3. Convert from equations to the matrix. From that matrix, minus 3. 3 minus 1, 2 minus 2 minus 2, 8 minus 3 minus 3, 10, 8, 10, 12. Solve this matrix. You will get I1 is 0.1, 6.0.1, 3.27, 3.38. From the mesh currents I1, I2 and I3, these currents determine current flowing through the 1 ohm, 2 ohms, 3 ohms, 4 ohms, 5 ohms resistor. Branch currents. 5 ohms resistor current is I3, that is 3.38. 4 ohms resistor is I2, that is 3.27. This 1 ohm resistor current I1 minus I2 from the top to bottom, I1 minus I2, that equals to 2.74, 6.01 minus 3.27. Next, I3 current is from I2, I3 from left to from right to left. This one minus 0.11. So this one I2 current is the I1 minus I3 from right to left, 2.63. Next problem. Determine current flow into the each resistor in a given network. Determine possible number of meshes. Mesh 1, mesh 2, mesh 3. And next, second step, assign the mesh current. Assume the mesh currents I1, I2, next I3. Apply KVL in each mesh using Ohm's law in terms of I1, I2 and I3. Here the raising voltage 8 volts minus 2.01, 2 into I1 minus 2 into I1 minus I2, 2 into I1 minus I3. 6, 2 plus 2 plus 2, 6, minus I2 minus 2 I3 is equals to 8. Second loop equation, 2 into I2 minus this one, 2 into I2 minus I1, 2 into I2, 4 into I2 minus I3. So this is raising voltage 6 volts, but in reverse direction, minus plus to minus, so you can take minus is equals to 0. Minus 2 I1, minus 2 I1, this one. Next 2 plus 2 plus 4, 8. Next minus 4 I3 is equals to minus 6. Third mesh equation, minus 2 I3 minus I1, this one, plus 6 flowing from minus 2 plus raising voltage, minus 4 I3 minus I2, this 2 I3 is equals to 0. Now minus 2 I1 minus 4 I2 plus 8 I3 is equals to 6. From the, you can calculate the I1, I2, I3. 6 minus 2 minus 2, minus 2, 8, -4, -2, -4, 8. 8 minus 6, 6. Solve this matrix. I1, I2, I3. I1 equals to 2 amps, I2 equals to 0.5 and I3 equals to 1.5. From this branch current, mesh currents, determine branch currents. So branch currents are 2 ohms, 2 ohms, 2 ohms, 2 ohms, 2 ohms, only 4 ohms. So here first 2 ohms, I1 is this one, this current is same 2 ohms. This 2 ohms is I2 current, same, this loop current I2. This 2 ohms resistor is this one, I3 current 1.5, this is 0.5, this one is 2. Next, this 2 ohms resistor current I1 minus I2 from the top to bottom, I1 minus I2 that equals to 1.5, 2 minus 0.5, from bottom to top minus 1.5. Next, this 2 ohms, this 4 ohms resistor I2 minus I3 from right to left, I2 minus I3 minus 1, I2 minus I3. Next, this I2 equals to I1 minus I3, 2 minus 1.5, that is 0. I think this one is plus I2 minus I3. Question number 5. Determine current flowing through the each resistor in this network. Same procedure, similar circuit. Solution for this. Determine possible number of meshes I1, I2, I3. Mesh currents I1, I2 and I3 in clockwise direction. Step 3. Apply KVL in each mesh using Ohm's law. 10 is equals to 1 into minus this one, minus I1, 3, I1 minus I2, 6, I1 minus I3 is equals to 0. 10 I1 minus 3 I2 minus 6 I3 is equals to 10. Equation number 1. The second mesh, in this mesh, 2 I2 minus 5, this one, 2 I2 minus 5 I2. Current is flowing from positive terminal to the negative terminal. So it is rising voltage, but in reverse the current is flowing from positive to negative. So minus 5, 3 I2 minus I1 is equals to 0. Minus 3 I1 plus 10 I2 plus 10 I3 is equals to 5. Equation number 2. Next, minus 6 I3 minus I1, this one. Current is flowing from negative terminal to positive terminal. So plus 5, 4 I3 minus 4 I3. So this is plus terminal to the minus terminal, 20 is equals to 0. Minus 6, 0 I2. There is no resistor. So 0, 10 I3. 6 plus 4, 10 I3 is equals to 25. Convert into matrix format and then solve it. 10 minus 3 minus 6, 10. Minus 3, 10, 0, minus 5. 6, minus 6, 0, 10, 25. By Kramer's method, I1, I2, I3. 4.27 is the I1, 0.78 is the I2, and I3 is the 5.6. Solve the branch currents. 1 ohm resistor current, 2 ohms resistor current, 5 ohm resistor current, 3 ohms resistor current, 6 ohms resistor current, and 4 ohms resistor current using this I1, I2, and I3. From the mesh currents I1, I2, and I3, determine the branch currents. First, I1 resistor current is the I1, this one, 1 ohms resistor current, and I2 and 5 ohms, I2 and 5 ohms, this 5 ohms resistor current, this one, I2, and this 4 ohms resistor current is the I3, and this 6 ohms resistor current I3 minus I1, and this I3 current is this one. So I1 minus I2 from the top to bottom, and I2 minus I1 from bottom to top. So I1 equals to 4.27, I2 equals to I2 ohms resistor current equals to 0.78, I4 ohms resistor current this equals to 5.06, I5 0.78, and I3 is equals to 3.49, I6 equals to minus 0.79. Next problem. Determine current flow into each resistor for this network. The diagram is very clear. Same procedure, same 5 steps you are supposed to follow. Step 1, determine possible number of meshes. 1, 2, 3. Next, assign the mesh currents in clockwise direction I1, I2, and I3. Next, KVL equation in the first mesh. 56. 5 into I1 minus I2. 2 into I1 minus I3. 2 into I1. This one. These 3 are voltage drops, and this one is the supply voltage. Next, second loop equation. If you simplify this one, 9I1 minus 5I2 minus 2I3 is equal to 56. That is equation number 1. Second loop equation, second mesh equation, 8. So minus 8, current is flowing from positive terminal to the negative terminal. Take minus 4I2 minus 1 into I2 minus I3 minus 5 into I2 minus I1. If you simplify this, minus 5I1, 1 plus 5 plus 10, this one I2, and this is minus I3, minus 8. Third mesh equation, 2 into I3 minus I1, this one. Next, 1 into I3 minus I2, this one. Next, 10 into I3. There is no voltage source in this mesh. The value is 0. The simplified equation, minus 2I1, this one, minus 1I2, this one, and 2 plus 10 plus 1, this one. Equation number 1, 2, and 3. 3 equations we have. From these 3 equations, you can write the matrix form. 9 minus 5 minus 2, 56. Minus 5, 10 minus 4, this one. Minus 1 is equals to minus 8. Minus 2 minus 1, 13 is equals to 0. Solve this. You will get 8I1, 3.67 and 1.60. From this mesh currents, determine current flowing through the each resistor, 10 ohms resistor current, 2 ohms resistor current, 1 ohm resistor current, 5 ohms resistor current, 2 ohms resistor current and 4 ohms resistor current. Write the branch current in terms of mesh currents. 2 ohms resistor current is the I1, this current, that is 8.61, and 4 ohms resistor current, I2 current, that is 3.67. Next, 10 ohms resistor current, I3 current, 1.60. This one, I3 current. Next, this 2 ohms resistor current is I1 minus I3, this one, 7.01. Next, this 5 ohms resistor current, I1 minus I2, this one, 4.97. Next, this 1 ohms resistor current, I2 minus I3. So these are the branch currents, each resistor currents. From this you can determine voltages, also multiply with resistance. Next concept is nodal analysis. Nodal analysis is the same purpose to determine the current flowing through the each resistor and voltage across the each resistor. Here the best method to find out the voltage across the each resistor is a nodal analysis. Here to understand this, we must know about node and junction. What do you mean by node? Node means two or more elements connected to one point. Here possible number of, here two elements, voltage source and this one connected to this resistor R1 connected to this point. Two or more elements, three elements R1, R4 and R2 are connected to this point. This is 1, this is 2 and this one is 3. This one is 4. This one is 5. This one is 6. This one is 7. And this one is 8. The number of nodes are 8. Now, possible number of junctions. What is meant by junction? 3 or more elements. 3 elements, not 2. 2 or more elements connected to one point is known as node, and 3 or more elements connected to one point is known as junction. Junction 1, here 3 elements, junction J1, junction J2, junction J3, junction J4. Total number of junctions are 4. J1, J2, J3 and J4. Now here the steps. What are the steps to follow nodal analysis? You are supposed to follow total 5 steps. Step 1, determine possible number of junctions. Here in this particular circuit, in this network, total 4 junctions. Assign the junction voltages V1, V2, V3 till Vn. If suppose n number of junctions, assign that junction voltages like V1, V2 and V3. Next, select one junction as a reference junction. You can select any one. Better prefer bottom one, J4. If suppose J4 is 0 or J4 voltage is 0, V4. Or you can take V3 also, you can take V2 also. Select one junction as a reference junction. That reference voltage should be 0. Next, step 3 is apply not KVL. Here KCL at junction, at each junction except that reference junction, apply KCL using Ohm's law in terms of V1, V2 and V3 till Vn. Now, solve that KCL equations. You will get V1, V2, V3 and V3. From this V1, V2, V3 till Vn junction voltages, you can determine voltage across the each resistor and voltage across current flowing through the each resistor. Step 5. From the junction voltages, determine the branch currents. Let us take one problem. Determine current flowing through the each resistor. In this network, current flowing through the each resistor. Step 1. Determine possible number of junctions. Here 3 elements connected to a point. Here 3 elements to connect at this point, and this total 1, 2, 3. Consider as a this one. Junction 1, junction 2, junction 3. Next step 2 is assign the junction voltages V1, V2 and V3 till Vn. Here 3 only. V1 is the junction 1 voltage and V2 is the junction 2 voltage and V3 is the junction 3 voltage. So select one junction as a reference. That reference junction is the voltage is a 0. Here that voltage, this I am selecting here V3 as a reference. Now apply KCL at each junction. So except that reference junction, apply KVL. Here we have only 2 junctions. Here you can apply. Here you can apply. Here the reference junction voltage is 0 means we cannot apply. Okay. Next, V1 voltage at junction J1. If you apply KCL means sum of entering currents at a node equals to sum of leaving currents, or algebraic sum of currents at a node equals to 0. Now here this current is entering means is equals side plus. If it is leaving away from the node means is equals side minus. So is equals side plus 1 this one, and V1 minus V2 by 2 ohms this one. And this one V1 minus V3 by 2 ohms. Current equals to voltage by resistance. Potential difference between, here is a potential V1 and here is a potential is a V3. The potential difference by resistance is known as currents. Currents this, and V3 V1 minus V3 is equals to 2. Now if you simplify this one, V1 1 by 2 plus 1 by 2, that is 1 V1, and V3 value is 0. This reference voltage is 0. Next, minus 0.5 V2 is equals to 1. This is equation number 1. Second mesh equation, second node equation, junction equal to, if you apply KCL at this node, next V2 minus V1 by 2, potential difference between these two divided by resistance, and V2 minus V3 divided by 1, and this is current, entering current. So 2 amps current is entering, so this is plus is equal side plus. The simplified equation, so minus 0.5 V1, 1 by 2 and 1.5 V2 is equals to 4. Equation number 2. Solve these two equations, KCL equation, you will get I1 and I2. Convert into the matrix format using Cramer's method. If V1 and V2 are the junction voltages. From this junction voltages, you can determine each resistor voltage and currents. Here currents from this junction voltages. So V1, this 2 ohm, I1 current, 1 ohm resistor current is I1, same. This current source current is the same. This I3 current is the, this current source current is the same, 2 amps, and I1 current. See this currents first. I1 current is 1 as it is current, and I3 current, this 2 amps current. But here this V1 minus V2 by 2 is the V1 minus V2 is the this one, 2 ohms resistor current, 0. Next V2 minus V3 is this one, 2 amps current, and V2 minus V3 by V1 minus V3 by this one is a 1 amp. So these are the current. If you want voltages also, you can multiply with resistance or V1 minus V2 like this. These are the voltages. So 2 ohms resistor voltage, 2 ohms resistor voltage, 1 ohm resistor voltage. Like this you can calculate. Question number 2. In the nodal analysis, determine current flowing through the each resistor in this network. Same, possible number of junctions, junction 1, junction 2 and junction 3. Determine possible number of junctions 1, 2, 3, and assume the junction voltages V1, V2 and V3, V1, V2 and V3. Select junction voltage. Select one junction as a reference junction. That reference junction is 0. Junction voltage is 0. Apply KCL at each. Except this reference junction, apply KVL. So here V1 minus 15 by 1000, V1 minus V2 by 220, and V2 minus V3 by, these two are connected in series. R equivalent is 470 plus not V1 minus 15 by 1000, V1 minus V3 by 47, and V1 minus V2 by 220. This one, the simplified one, 2.68 V1 minus 0.45 V2 is equal to 1.5. Next, if you apply KCL at this node here, V2 minus V1 by 220 and V2 minus V3 by 150, V2 minus V3 by, these two are connected in series. Series connection 470 plus 150, this one. So 3 currents at a node equals to 0. There is no current source, is equal side 0. So minus 0.454 V1 plus 1.29 V2 is equal to 0. Solve these two equations, convert into matrix form. 2.68 minus 0.45 is equal to 15, minus 0.45 plus 1.29 is equals to 0. If you solve it, you will get V equals to 0.62 and V1 equals 0.62 and V2 equals to 0.26. From this junction voltages V1 and V2, calculate the currents. So 1000 ohms resistor current 14 milliamps, V1 minus 15 by 1000, V1 equals to this one, and 220 ohms resistor current V1 minus V2, this one 1.7. Substitute this V1 and V2 in this, and V1 minus V3 by 47, this one 12.7. V2 minus V3 by 470 plus 100, this one, and this current same current flows to the each element. Next, V2 minus V3 by 150, that equals to 1.3. Question number 3. Current flowing through the each resistor. In this, total how many branches, how many junctions? Junction 1, 2, 3, 4. So assume the junction voltages V1, V2, V3, V4, 1, 2, 3, 4, V4, and select one junction as a reference junction, that voltage equals to 0. Apply KCL at each junction. V1 minus V2, V1 minus V2 by 5 and V1 minus V3 by 4 is equals to minus 1. Here current is leaving away from the node. Next, 0.45 V1 minus 0.2 V2. Next, 0.25 V3 is equal to minus 1. Equation number 1. Next, V2 minus V1 by 5 and V2 minus V4 by 1 is equals to 2. This is entering current, plus 2. Minus 0.2 V1 plus 1.2 V1 plus 0 V3 is equals to 2. Equation number 2. Next, if you apply KCL at this node, V3 minus V1 by 4, V3 minus V4 by 4, 2 is equals, leaving current is a minus. Next, minus 0.25 V1, 0 V2, 0.75 V3 is equal to minus 2. Now from these three equations, you can calculate the V1, V2, V3. This is matrix format. V1, V2, V3, minus 4, 1, minus 4. Next, step 5 is from this junction voltages, calculate the branch currents. So 5 ohms resistor current V1 minus V2 by 5. This one minus 1. 4 ohms resistor current is the V1 minus V3 this one V1 minus V3, this is 0, same values, minus 4 and minus 4. Next, V2 minus V1 V4 by, this is 1 ohm resistor and this is 1 amp. Next, V3 minus V4 by 2, this one. Next, loss problem. Determine current flowing through the each resistor, this one, in a given network. Here, possible number of junctions J1, J2, J3 and J4. Assume the junction voltages V1, V2, V3, V4. Now here V4 value is 0. Select one junction as a reference junction. That reference junction voltage is in. Accept that reference junction, apply KCL at each junction using Ohm's law in terms of V1, V2, V3 and V4. Apply KCL. Step 4. V1 minus 20 by 3, V1 minus V2 by 1 and V1 minus V3 by 2 is equals to 0. So that means 1.83 V1 minus 1 V2 minus 0.5 V3 is equal to 6.67. V2 minus, at this, V2 minus V1 by 1 and V2 minus V3 by 6, and this is entering current is equal to 5 plus 5 is equal to 7. Next, the simplified equation minus 1 V1 plus 1.17 V2 minus 0.17 V3 is equal to 5. Equation number 2. Next, if you apply KCL at this node, at this junction, V3 minus V1 by 2 and V3 minus V4 by this one, V4 by this 5 and V3 minus V2 by 6. Here V4 equals to 0 now. So the simplified equation minus 0.5 V1 minus 0.17 V2 plus 0.087 V3 is equals to 0. Solve this KVL equation. So convert it to the matrix form. 1.83 minus 1, 0.5 this one, minus 1, 1.171, 0.175 this one. Next, minus 0.5, 1. This one, 0.17, 0.87 is equals to 0. So here you will get V1 equals to 23.82, V2 equals to 27.040 and V3 equals to 19.04. So from this junction voltages, calculate the branch currents. So these are the junction voltages. From this junction voltages, this 1 ohms resistor current equals to V1 minus V2 by 2. This one, that is minus 3.54. Substitute this V1 and V2. Next, I2 ohms resistor current is V1 minus V3 divided by 2.39. Next, this I6 current is this V2 minus V3 by 6, this one, and I5 current is a V3 minus V4. V4 value is 0 now, minus 3.8. If you still have any doubts in this lecture, you can comment in the comment section. I hope all these things are clear to you. Thank you. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.